Hey everyone, today we're looking at the paper Retrieval-Augmented Generation for Knowledge-Intensive NLP Tasks by a bunch of authors from Facebook AI Research, UCL and NY University. The paper focuses on the problem of integrating external knowledge into sequence-sequence models, which is kind of a more recent exciting problem people have been working on. And the basic idea is that you want to equip sequence-sequence models for diverse tasks like open domain question answering, or even translation or summarization. You want to equip those models with access to external databases which might contain factual knowledge. For example, it would be useful to be able to have access, some sort of adaptive access to all Wikipedia articles during the generation process to retrieve information about people, about things that happen, events or history, or pretty much everything. And in this paper they are proposing a new model, RAG, which consists of two components. First of all, we have a standard sequence-sequence model. It's actually a transformer encoder-decoder model. They use a model called BART, which is a transformer that has been pre-trained on large amounts of raw data. It's trained to on denoising tasks. So they have this BART model as a base, but they also have a special component, the retriever here, which basically takes as input the input sequence. For example, this could be a question like define what is middle ear. You take this as a query, and then you apply some retrieval model to find closed documents from a database such as all Wikipedia articles. And you retrieve those documents, and then you input those documents as well as the input sequence to a standard sequence model like BART. You condition the generator on all of these to generate the final answer, like the middle ear includes the tympanic cavity and the 3 ossicles. And the idea is you want to integrate these external documents because you want to have a more informed, more factually correct response generated. And this is a general setting. It works for pretty much all sequence tasks potentially, and potentially all of them might benefit, even though the authors in the paper focus on stuff like question answering, question generation of Jeopardy questions, and fact verification. So this is the overview, and importantly the authors propose 2 flavors of this model which they call RAG. The first flavor, RAG sequence, is retrieving only a single document from a database and only conditioning the generator on a single document. The second version, RAG token, is actually retrieving a collection, let's say 5 documents, and then during the generation the generator is able to switch between the different documents, which might be beneficial in particular if they contain quite diverse information. So for each token you might be able to access different facts from those articles to support your generation. For example, for the middle ear output here, we have tympanic cavity and 3 ossicles as 2 kind of factual statements, and having access to 2 articles and being able to switch back and forth between them might be leading to some benefit during the generation process. So this is the overview of the model, and they do perform a lot of experiments on different data sets. First on open domain question answering, a number of benchmarks here. It seems that RAG token and sequence outperform previous approaches. I think they achieve state of the art, I think they claim here in this paper on these data sets. They outperform, first of all, a T5 model, which is again a pre-trained transformer model, which is not using external knowledge, but basically it's relying on its parameters which can still memorize a lot of useful facts to integrate it to the output. So they're able to outperform the T5 model, and they also outperform some previous methods which also use integrate external knowledge using different approaches like Realm or DPR or some previous papers on this subject. When it comes to question generation, they do some experiments on the interesting task of Jeopardy question generation, where RAG token and RAG sequence again are kind of outperforming a BART model, which is again a pre-trained sequence transformer. And this task is pretty cool, I find, because it's I think it's pretty interesting because it really requires a lot of external knowledge to generate a good answer. And actually they have a cool example here where they demonstrate how it works. So in this example, the model is provided with the input Hemingway, and it's supposed to generate a question, Jeopardy question, from this. And when using the RAS token model, the model is able to retrieve 5 documents here, shown in this distribution here. And in particular, the top 2 documents are about 2 novels of Hemingway, A Farewell to Arms and The Sun Also Rises. And the system is able to generate the question, The Sun Also Rises is a novel by this author of A Farewell to Arms, which is able to use information from the 2 documents, and also they show some distribution over those documents where it seems that the system is able to focus on different documents during the generation process, which is cool as well. So I think those are the main things that I wanted to cover. In overall, it's an interesting architecture, interesting approach to integrating external knowledge into sequence models. Would have been interesting to see if it's possible to use this for some more general tasks like summarization or machine translation, but obviously the effects of using this external knowledge is the greatest for these tasks presented in the paper potentially. And yeah, for more details check out the paper, and thanks for watching.